All right, welcome. Today, we are going to break down one of the most important ideas in all of artificial intelligence, supervised learning. And I promise, by the end of this, you're going to walk away knowing exactly how machines learn to think with a little help from a teacher. So, let's get started.
It really can seem like magic, can it? But it all boils down to this one simple question. How does a computer go from being a blank slate to being able to predict things, or sort your emails, or even identify a cat in a photo? Well, it turns out, for a huge chunk of AI, the answer is surprisingly human. That's right. The most common way we get a machine to learn is by giving it a teacher. Well, maybe not a person standing in front of a chalkboard, but we give it data that acts like a teacher. Data that's full of examples with all the correct answers already provided. So just think about how you'd teach a little kid about fruit. You'd show them a picture of an apple and you'd say, this is an apple. Then you'd show them a banana and say, this is a banana. You do this over and over, and pretty soon you can show them a picture of an orange, something they haven't seen before, and they'll get it right. They've learned the pattern. That right there, that's the whole idea.
Okay, so let's make that jump. We're taking that exact same show and tell logic, that same simple idea of learning from examples, and we're just applying it to computers.
And that brings us to the official term, supervised learning. It's just a fancy way of saying the machine learns from data that's already been labeled with the right answers. So that picture of the apple, that's your input. And the word apple, that's the label, the correct answer. The machine's entire job is to figure out the rule that connects the input to the output. Now, once a machine starts learning like this, we usually ask it to do one of two main things. You can think of it like coming to a fork in the road. And we're going to explore both paths starting right now. So path number one is what we call classification. And really, it's all about answering a simple question. What is this thing? It's about sorting, about putting things into the right buckets or categories. Basically, the model's job is to pick from a list of options that we've already given it. So, is this email spam or not spam? Is this medical scan showing disease or no disease? The answer is always one of those predefined categories. So check this out. This is a perfect example, a spam filter. We feed the machine learning model thousands, even millions of emails where we, the humans, have already labeled them. This one's spam, this one's not. The email text is the input, and our label is the teacher saying, yep, you got it right. And after seeing thousands of these, the model starts to pick up on patterns, right? It learns that words like win, prize, or free are a pretty big red flag for spam. The key thing to remember is that the final output is always a specific, distinct category.
Okay, let's back up and take that other fork in the road. This second path is called regression, and it's built to answer a totally different kind of question. It's not about what is it, but how much or how many.
See, with regression, we're not predicting a category. We're predicting a number. It's a continuous value. We're not asking what something is, we're asking for a specific amount. Like, what's the price of this house going to be? Or what will the temperature be tomorrow afternoon?
And the classic example here is predicting house prices. Our inputs are things we can measure, like the square footage or the number of bedrooms. And the label? Well, that's the actual selling price of the house. That's the correct answer we teach the model with.
And you guessed it, the model starts to spot the relationships. It learns that, hey, generally, when the square footage goes up, the price tends to go up too. The crucial difference is that the output isn't a category like spam. It's a specific number, a price. Okay, so we've explored both paths. We've seen how machines can sort things and how they can predict numbers. Now let's just put them side by side to make it crystal clear.
Look, if there's one thing you take away from all this, it's this right here. Classification predicts a category, like sorting things. Regression predicts a number, like estimating a value. That's it, category versus number.
So let's just put it all together in one place. Classification, the output is a category. Think spam filters or figuring out if a picture is an apple or a mango. Regression, the output is a number. Think predicting house prices or forecasting the stock market. Two different kinds of problems, two different kinds of answers. Okay, so why does any of this actually matter? What's the big deal? Well, because when you get right down to it, this isn't just about computers and data. It's about giving machines something profoundly human, the ability to learn from experience. And this quote, I think, just nails it. It doesn't matter if we're teaching a machine to spot spam or to predict the housing market. The fundamental idea is exactly the same. We are giving it examples, and it is learning from that experience. So at the end of the day, this whole thing, supervised learning, it's not some kind of black magic. It is a powerful, repeatable method for letting machines look at the past, look at all those labeled examples, so they can make really smart predictions about the future.
And that really leaves us with a pretty incredible question to think about. We have actually figured out how to give machines a way to learn from experience. So the only real question left is, what amazing, world-changing problems are we going to teach them to solve next?